What's up guys, this is Massey. Welcome to another video. In this video I want to talk about finding the greatest term in expansion of x plus a to the power of n, or sometimes called the greatest numerical value in the expansion of x plus a to the power of n. So I just go over the explanation quickly and then you digest it more in doing some example. The numerical value of the greatest term in the binomial expansion of x plus a to the power of n for given values of x and a is obtained as follows. When we have x plus a to the power of n, we can take a to the power of n out and have it as 1 plus x over a to the power of n, and then we change x over a to capital X. So a to the power of n times 1 plus capital X to the power of n, where capital X is x over a. Now you find x, you have n. So if m equals to n plus 1 times absolute value of x divided by 1 plus absolute value of x is an integer and is equal to m, then tm and tm plus 1 are the numerically greatest term in expansion of 1 plus x to the power of n. If it's not an integer, then the integral part of m is going to be considered and tm plus 1 is going to be the numerically greatest term in expansion of 1 plus x to the power of n. Let's see some examples so you can learn it better. So here in this first example, it says find the numerically greatest term or terms in the binomial expansion of 1 minus 2x to the power of 12 for x equals to 1 over 5. So the formula we have is n plus 1 times absolute value of capital X over 1 plus absolute value of capital X. So now let's find out capital X first. It is 1 minus 2x to the power of 12 and x is 1 over 5. So it's going to be 1 minus 2x to the power of 12, and then when you take 1 out it doesn't change anything, so we can say x is going to be negative 2x, which is going to be negative 2 times 1 over 5, and that's going to be negative 2 over 5. Now when we sub it there, n is 12 plus 1. Absolute value of capital X is going to be negative 2 over 5 divided by 1 plus absolute value of negative 2 over 5. So that's going to be 13 times 2 over 5 divided by 1 plus 2 over 5, which is going to be 7 over 5. That's going to be 26 over 5, which is going to be 5 over 7. So it is not an integer, but the integral part is 3. It means that the fourth term is going to be the greatest term, or the T4 is the numerically greatest term in expansion of this 1 minus 2x to the power of 12. So I'm going to say T4 equals to, index is 12, so 12C3 as we had before. We know already how to make it. We had it in many videos before. Then time 1 to the power of 12, which is going to be nothing, minus 2x, which is going to be negative 2 over 5 to the power of 9, because that's going to be 12 minus 3, or it's better to say 3 here, because here the r plus 1 is 4, so that's going to be 3 here. So 12C3 is going to be 12 times 11 times 10 divided by 3 times 2 times 1, negative 2 over 5 to the power of 3. So when you calculate it, this 6 cancel out with this one is going to be 220 times negative 8 over 125. Then the answer is going to be negative 352 divided by 25. Now next one, it says find the numerically greatest term in the binomial expansion of 2x minus 3y to the power of 19 when x is 1 over 4 and y is 1 over 6. So that's going to be 2x minus 3y to the power of 19. You take the 2x to the power of 19 out. Then you have 1 minus 3y over 2x to the power of 19. X is going to be negative 3y over 2x. And the number is going to be negative 3, 1 over 6 to 1 over 4. That's going to be negative 1 over 2, 1 over 2, which is going to be negative 1. So x is going to be negative 1, capital X. So when we put it in the formula, m equals to n plus 1 times absolute function of x over 1 plus absolute function of x. So n in this case is 19. 19 plus 1 is going to be 20. Absolute function of negative 1 divided by 1 plus absolute function of negative 1. That's going to be 20 divided by 2. That's going to be 10. Absolute function of negative 1 is 1. 1 plus 1, 2. And here we have 20. 20 divided by 2 is going to be 10. So since this number is an integer, we can say T10 and T11 are the numerically greatest term in this binomial expansion. So T10 and T11. Let's write out T10 first, which is going to be 10. Here n is 19. 19C. 19C9. 2x to the power of 19 minus 9, which is 10, times negative 3y to the power of 9. So that's gonna be 19C9, and here 2x, we can substitute the numbers. X is 1 over 4, so it's gonna be 1 over 2 to the power of 10, and here we have negative 3y. Y is 1 over 6, so it's going to be negative 1 over 2 to the power of 9. So that's going to be negative, so it's going to be negative 19C9, 1 over 2 to the power of 19. Now we can do the same thing with T11, 19C10. 2x to the power of 9, negative 3y to the power of 10, 19C10. 2 times x is going to be, x is 1 over 4, is going to be 1 over 2, 9. Negative 3 times 1 over 6 is going to be negative 1 over 2 to the power of 10. This time is going to be positive, so that's 19C10, 1 over 2 to the power of 19. So we can say T10 equals to negative T11. We had it in explanation here before. It says if m is an integer and is equal to m, then Tm and Tm plus 1 are both numerically greatest term in expansion of 1 plus x to the power of n. In this case, note that the absolute function of Tm equals to the absolute function of Tm plus 1, and that sometimes Tm and Tm plus 1, they are not equal to each other, but they are equal to negative of each other. So Tm equals to plus minus Tm plus 1. So that's exactly what we have in here. T10 equals to negative T11. So now let's look at this example. It says find the greatest term in 5 plus 2y to the power of 17 if y equals to 1 over 2. So the first thing I'm going to do, 5 plus 2y to the power of 17 is going to be 5 to the power of 17. 1 plus 2y over 5 to the power of 17. So, capital X in this case is 2y over 5, which is going to be 2 times 1 over 2 divided by 5, and that's going to be 1 over 5. Now let's calculate the value of m, which is n plus 1 times absolute function of x over 1 plus absolute function of x. That's going to be 18. Absolute function of x is going to be 1 over 5. 1 plus 1 over 5. That's going to be 18 times 1 over 5. 6 over 5. That's going to be 3. So m is 3. It means that since it's integer, t3 and t4 is going to be the numerically greatest term. So t3, which is going to be 17 c2, because this one is r plus 1. So r is 2 times 5 to the power of 17 minus 2, 15, times 2y to the power of 2. 17c2 is going to be 17 factorial divided by 2 factorial divided by 15 factorial. So 16 times 17 divided by 2 is going to be 17 times 8. That's going to be 136. 5 to the power of 15. 2 times y, which is 2 times half, that's going to be 1 squared. So 5, so it's going to be 136. 5 to the power of 15. So that's going to be t3. Now let's look at the t4. That's going to be 17 c3, 5 to the power of 14, 2y to the power of 3. So 17 factorial divided by 14 factorial divided by 3 factors, so 17 times 16 times 15 over 3 times 2 times 1, 5 to the power of 14, and this one is going to be 1 to the power of 3, which is going to be the same. So 15 times 16 times 15 divided by 6, 680 times 5 to the power of 14. So when you calculate both of them, let's figure out the first one. 136 times 5 to the power of 14. That's a huge number. That's gonna be 8.30078 times 10 to the power of 11. And this one, 680 times 5 to the power of 14. It's gonna be exactly the same number, 8.30078 times 10 to the power of 11. So as you see here, t3 and t4 are the same thing. So now next example, it says find the numerically greatest term in the expansion of 3 minus 2x to the power of 8 when x is 1. So 3 minus 2x to the power of 8. That's going to be 3 to the power of 8, 1 minus 2x over 3 to the power of 8. So capital X is going to be negative 2x over 3. Negative 2 over 3, x is 1, is going to be negative 2 over 3. Now if we want to find out m, is n plus 1, absolute function of x, over 1 plus absolute function of x. That's going to be n plus 1, that's going to be 9. Absolute function of x is going to be 2 over 3. 1 plus absolute function of negative 2 over 3, which is going to be 2 over 3. That's going to be 9, 2 over 3, 5 over 3. That's 18 over 5. And since it's not an integer, we need to find out the integral part, which is going to be 3. So 3, it means that 3 plus 1, t4 is going to be the numerically greatest term. T4 is 8c3 times 3 to the power of 5 negative 2x to the power of 3. That's going to be 8, 7, 6 divided by 3, 2, 1. 3 to the power of 5. Negative 2 times x. X is 1. Negative 2 to the power of 3. Going to be That's 56. 3 to the power of 5 is going to be 253, I guess. 243. 3 to the power of 5, 243. And negative 2 to the power of 3 is negative 8. So 56 times 8 times 248 is going to be negative 111,104. 111,104 is going to be the numerically greatest term. Let's look at the next example. Find the numerically greatest term in the expansion of 1 plus 2 over 3x to the power of 8 when x is 3 over 2. So 1 plus 2 over 3x to the power of 8 is going to be, x is going to be 2 over 3 times 3 over 2, which is going to be 1. M will be n plus 1 times absolute function of x over 1 plus absolute function of x. So that's 9 times 1 divided by 1 plus 1. That's 9 divided by 2, which is going to be, since it's not an integer, you need to find out the integral part, which is going to be 4. So 4 plus 1, 5. So T5 is the numerically greatest term. So T5 is 8C4 times 1 to the power of 8 minus 4, 4. 2 over 3x to the power of 4, which is going to be 8 times 7 times 6 times 5 divided by 4 times 3 times 2 times 1. 2 over 3 times 3 over 2, 1 to the power of 4 is going to be 1. So 2 over 2 and 3 cancel out with this 6. 8 and 4 is going to cancel out. It's going to be 2. 2 times 5, 10. 10 times 7, 70. See, you don't need to use the calculator sometimes. Find the numerically greatest term in the expansion of 2a plus b to the power of 11 when a is 4, b is 5. So 2a plus b to the power of 11 is going to be 2a to the power of 11, 1 plus b over 2a to the power of 11. So x is b over 2a. That's 5 over 2a, which is going to be 8. And then we can say m equals to n plus 1 x over 1 plus absolute function of x. So that's 11 plus 1, 12 times 5 over 8. And here you have 1 plus 5 over 8 is going to be 13 over. So that's 60 over 13. 60 over 13 is going to be 4. 8 over 13. So 4 is the integral part. 4 plus 1, 5. So T5 is the numerically greatest term, which is going to be 11C 4 2a to the power of 7 b to the power of 4, which is going to be 11C4 2a, which is going to be 8 to the power of 7. b is 5 to the power of 4. That's going to be the answer to this question. Next one. Find the numerically greatest term in the expansion of 2x minus 12 to the power of 28 when x is 9. So 2x minus 12 to the power of 28 is going to be 2x to the power of 28. 1 minus 12 divided by 2x to the power of 28. So capital X is 12 over 2x, which is going to be 12 divided by 18, or that's going to be 2 over 3 when you simplify it or reduce it. M will be n plus 1 times absolute function of x over 1 plus absolute function of x. That's going to be 28 plus 1 is going to be 29. 2 over 3. 1 plus 2 over 3 is going to be 5 over 3. So 28 times 2. That's going to be 58 divided by 5. That's 1135. So, since it's not integer, the integral part, 11 plus 1, 12. So T12 is the numerically greatest term, which is going to be 28 C11, because that's R plus 1. R is going to be 11. 2x to the power of 28 minus is going to be 17 times negative 12 to the power of 11. And 2x is going to be 2 times 9, 18. So 28, 18 to the power of 17, negative 12 to the power of 11. That's going to be a very huge number. Find the numerically or numerical value of the greatest term in 2 plus 3x to the power of 12 when x is 5 over 6. So 2 plus 3x to the power of 12. It's going to be 2 to the power of 12. 1 plus 3x to the power of divided by 2 to the power of 12. So x is 3x over 2. X is 5 over 6. So 3 over 2. 5 over 6 is going to be 15 over 12. That's going to be 5 over 4. So m is n plus 1 times absolute function of x over 1 plus absolute function of x. n plus 1, 13. 5 over 4. 1 plus 5 over 4. That's going to be 9 over 4. Cancel out. 5 times 13 is going to be 65 divided by 9. 65 divided by 9. That's going to be 6. Actually 7. Because 7 times 9 is 63. 2 over 9. So 7 is the integral part plus 1, 8. So T8 is the numerically greatest number, greatest term. T8 is 12C7 2 5 3x to the power of 7. 12C7 2 to the power of 5. 3 times, it's going to be 5 over 6. So 15 over 6. That's going to be 5 over 2 to the power of 7. So that's going to be the numerically greatest term. I hope you enjoyed this video. Please leave me a comment if you have any question. And please don't forget to subscribe to this channel. You can have access to many other videos regarding binomial expansion and other topics in math, physics, and chemistry. And please also don't forget to recommend it to your friends and colleagues. Thank you so much. Thank you for watching and have a great day.